Welcome to the deep dive. You send over this really fascinating collection of research, and it's all about how visual displays, sometimes they're called VDs for short, impact learning.
Uh-huh.
And we're talking students from kindergarten all the way up through 12th grade. I mean, we've got systematic reviews, individual studies, using a bunch of different approaches.
Right.
What we really want to do in this deep dive is pull out the most important stuff from all of this for you. So we really understand how these visuals, these displays, they affect learning.
Absolutely.
And it's more than just, aesthetics or making things kind of pretty or easier to communicate. This is about the nuts and bolts of how students are actually grasping information and holding on to it.
Yeah, exactly. I mean, we want to go beyond, visuals are just a nice thing to add. We want to look at okay, based on what you sent, when did they really make a difference in how kids learn?
So let's just start with some basics. What exactly are we even talking about when we say visual displays or VDs? I mean, it sounds like it's more than just an image next to some text, right?
Right, yeah. The research defines those visual displays as graphical texts. So
Hmm.
they rely a lot on how things are arranged in space and the visual representations of information. Of course, this includes all the usual suspects,
That's
like diagrams, charts, graphs, all that stuff you see in textbooks. But it includes multimedia elements too. But one thing to keep in mind with all the research you sent over is that the focus is mostly on static displays,
Okay.
not so much the dynamic stuff like videos or simulations or things like that. So, it's really about how the information is visually structured and presented.
Okay. So it's really the visual architecture of the information.
Right.
And it seems like even how researchers think about categorizing these visuals has kind of changed. I mean, you mentioned in the research, older approaches kind of stuck to these simple, this versus that, representational versus not. What prompted that shift?
Right. Well, as you know, those learning materials have gotten more and more, I guess you could say, sophisticated,
Yeah.
visually rich. Those simple categories, they don't cut it anymore. Think about a page in a modern textbook.
Yeah.
You might have a photograph, but then it's got all this stuff on it, labels, arrows pointing to things, maybe even a diagram on top of that.
Right.
It's tough to say if that's purely one thing or the other. So this term VDs, it gives us a broader way to look at all these complex visual elements that they're everywhere in learning now.
Okay, that makes sense.
Uh,
So we know what we're talking about. Now, one thing that really stood out was this. Just adding visuals, it doesn't automatically mean better learning. In fact, the research was there were some mixed results in that. Some said it helped, others said no impact at all, some even said it hurt. What explains that?
well, that's a big question. And it kind of highlights this. Learning from visuals, it's like learning from text in a way. It takes work from the student. Some early research, it said that just having visuals there, it helps comprehension. And maybe in some cases that's true,
Yeah.
but a more complicated picture has kind of come out since then. Research shows that if a student doesn't have the background knowledge or if the visual isn't designed well, they might get the wrong idea from the visual. Also, if it's just repeating what's already in the text and not adding anything new, it might not help at all. It could even be distracting, especially for younger students or if they aren't strong readers.
Right.
So basically, it's not like a magic bullet. You don't just slap on a visual and boom, better learning. It depends on a lot of things.
Right, right. It's not as simple as a picture's worth 1,000 words or whatever, right? Now, the research gets into how students actually interact with these VDs. It splits them into two groups.
Yeah.
Author-provided visuals, so the stuff that's given to them in the textbook, and then student-constructed, where they're making it or completing it.
Yeah.
Let's start with those author-provided ones, what they call learning by viewing.
All right. Well, within those author-provided visuals, there's another split. You have concrete visuals, photographs, realistic drawings, that kind of thing. And then you have the abstract or schematic visuals like diagrams, flowcharts, concept maps. Now, with the concrete visuals, what the research says is how much they help depends on how well students can actually connect them to the text.
Okay.
And it's interesting, some studies even found that, sometimes just text alone is as good as text with a concrete visual.
Really? Yeah, that's surprising. You'd think an image would always help you understand better.
Right. Well, what they think is happening is if that visual is just like a direct illustration of what the text is already saying, it might not make the student think harder or give them any new insights.
Right.
So the key seems to be, does the student use the visual to build up a deeper understanding beyond just the literal stuff in the words? They even found these students they called high integrators. So these are the kids who are really good at connecting the visual cues to the story the text is telling. And those are the students who showed better comprehension. So it's not just about passively looking, it's about making those connections.
So it's about like actively processing the image in relation to the text, and that's what matters. Okay, so what about those abstract visuals, like diagrams or flowcharts? I mean, those seem super useful for like organizing complex information, showing relationships, that kind of thing.
Yeah, they definitely have that potential. But the research shows kind of inconsistent results there. Sometimes they help, sometimes they don't make much difference. And that suggests, while they can be powerful for showing those complex relationships in a nice, neat way, they also might require more brain power from the student
Okay.
to interpret what they're seeing and make
Yeah.
sense of those, abstract representations.
Right.
So the inconsistency, it might come down to things like how clear the design is, how much experience the student has with those kinds of visuals, and how much support they're getting to understand what all the little bits and pieces mean.
Okay, so this is where it gets really interesting. The research talks about different things that can boost how effective those abstract visuals are. Things like adding in cues and signals, using analogies, and even mixing up the types of visuals you use. Let's start with cues and signals. So things like captions, arrows, that sort of thing. What kind of impact do those usually have?
Well, the idea there is to guide the learner's attention to the important stuff and highlight the connections within the visual. Like captions, they can give context. Color coding can draw the eye to certain categories or elements. Labels can identify different parts, and then arrows can show direction or relationship.
Right.
And the principle behind that is to make the visual more accessible and help the learner build that mental picture of what's going on.
Okay.
But what this review points out is that the impact of all those little design elements, it's kind of mixed. How much they help is often tied up with how much support the teacher or the material itself is giving.
Right.
So it's hard to say for sure if it's the visual design alone that's making the difference. But they do mention a study where they directly taught students how to interpret those common diagram things.
Like what the different lines and arrows mean.
Yeah, exactly. And that did lead to better understanding of biology diagrams. So the visual design can work, but you might have to actually teach kids how to read those cues,
It's its own little language.
Right, exactly.
Yeah. Okay. So what about using analogies within the visuals? It seems like that could be a powerful way to connect new abstract concepts to things students already get.
Totally. Visual analogies can be like a bridge. They help link the new stuff to what students already know, and that can really boost learning and reasoning. The research mentions a bunch of studies where students who use diagrams with analogies built in, they showed big improvements in science learning.
Okay.
Like, for example, if you're teaching about electricity, you could use a visual analogy that compares the flow of electricity in a circuit to water flowing through pipes. Makes it easier to grasp, right? And it seems like visuals are really good at showing those structural similarities between concepts. Analogies just make more sense when you can see them.
I get it, yeah. Seeing that comparison laid out visually, that could really help build understanding. What about combining different types of VDs? Say you've got a diagram, but then you also have a photograph or a chart with data. Does that combo tend to be better?
The research says that when students can work with a variety of visual displays, pictures, diagrams, charts, timelines, graphs, all of that, their overall understanding of the text tends to be better. In fact, one study found a really strong link between third graders' ability to make sense of different visual formats and their overall reading comprehension. So it looks like being comfortable with all those different visual formats is a big part of developing literacy in general.
So it's like you need exposure to different visual languages, and you need to build up those skills to interpret them. Okay, that was a good look at the author-provided visuals. Let's switch gears to those student-constructed VDs, where they're the ones doing the creating or completing. Now, the research breaks those down further into student-filled-in and student-created. What's the difference there?
So student filled in VDs are kind of like pre-structured visuals, think partially filled out graphic organizers or diagrams. The student's job is to fill in the missing info, labels, connections, things like that. But student created VDs, that's where they're doing the whole thing themselves. They decide what info is important, how to show it visually, and then they build the whole visual from scratch. Much more independent.
So fill-in is more guided. They have that framework to work with. And created is more like, okay, go figure this out and show it to me. Let's stick with the filled-in ones for a minute. What's the research say about how well those work? I noticed they mentioned a focus on students with learning disabilities.
Yeah, a lot of the research looked at how these filled-in visuals impact kids with different learning challenges, reading problems, math problems, that kind of thing.
Right.
And the results are pretty positive and consistent. It seems like these structured visuals give those students really valuable support, helping them organize info, spot those key relationships, and filter out the less important stuff.
Makes sense, yeah.
Studies showed that both average readers and those with learning disabilities, they did better in comprehension and applying what they learned in subjects like English and social studies when they used these filled-in organizers. It's like that structure takes some of the mental load off their shoulders. They don't have to figure out how to organize it all themselves.
That makes sense. It's like a built-in support system. Okay, so what happens when they have to create the visuals entirely on their own? That seems like it takes a lot more brain power, higher level thinking.
Absolutely, it does. When students create their own VDs, they're tapping into those higher order thinking skills. Most of the research here focused on upper elementary and high school, and the findings are really promising. They found that when students created their own diagrams, concept maps, those mixed visuals we talked about, even just drawings to go with what they read, it led to big improvements in learning across different subjects. It seems like the act of creating those visuals forces them to really process the info deeply, figure out the most important connections, and then put their understanding into a new form visually. And that process seems to really make the learning stick.
Wow, so the act of creation itself is like a key part of learning. Now, they did mention there isn't as much research with younger kids creating their own viddies, but there's some early stuff, especially around image creation and vocabulary for science.
Right. Most of the research is on older students, but it does seem like even young kids can benefit from creating visuals, especially when it's tied to hands-on activities.
Okay.
Or they're drawing simple pictures to go with new words. But here's the thing, the research really stresses this. If you want those student-created visuals to be effective, you gotta give them support. Scaffolding, modeling how to do it, giving them feedback, all of that's crucial. You can't just say, make a diagram and expect them to learn a ton.
Right. You got to teach them the language of visuals, give them the tools. Okay, that makes sense. And this leads us to, I guess, what makes those visuals work even better, instructional support. The research breaks it down into content, so teaching about the subject itself, strategies and activities, and then the length of time spent working with visuals. Let's start with content. What kind of teaching about the subject matter seems to make a difference when you're using visuals?
So a few things stand out. First, teaching basic literacy skills, that's like the foundation. There are studies that show that if you teach students about story grammar, the basic parts of a story and how it's structured before they use graphic organizers to map out the story, it can really help their reading comprehension, especially for kids with learning disabilities.
Okay.
So if they understand how stories are built, they can use that organizer better to show it.
So it's like the visual tool works better if they've got that literacy foundation to build on. What about instruction on how to actually understand the visuals themselves? They call it visual convention instruction.
Yeah, so that's directly teaching students how to read and understand all those little things in visuals, how to interpret different diagrams, what symbols and icons mean, how to follow the relationships shown by lines and arrows in those organizers.
Right.
Now, this is often combined with other teaching strategies, but some research suggests that just teaching those visual conventions on their own can lead to big improvements in things like math problem solving and overall understanding of diagrams.
Yeah.
It's basically teaching them the grammar of visual communication so they can decode and interpret that info better.
Right, like it's own language, like we were saying.
Exactly. You can't just throw a complex diagram at them and expect them to magically understand it. They need guidance.
Makes sense.
Yeah.
Now, they also mentioned giving content-specific instruction before using VDs. So, like, teaching about the topic before they see the visuals. What does the research say about that?
The thinking there is that if students have a good grasp of the basics and the key concepts before they see the visuals, they'll be able to learn more from them. There are studies that have done this, taught the content first, then used VDs in subjects like math, science, safety education. But this review points out that there's not a lot of research that looks at just the effect of that upfront content instruction in isolation. Yeah. It's usually part of a bigger approach.
Right.
But logically, it makes sense, right? If you understand the concepts better, you should be able to engage with the visuals in a more meaningful way.
Yeah, it seems intuitive.
Yeah.
Okay, let's move on to those strategies and activities that can boost learning with visuals. They talk about feedback, peer collaboration, self-explanation, those metacognitive strategies. Let's start with feedback.
All right, so teacher feedback, that's super important. When teachers give specific feedback as students are working with visuals, to clear up confusion, correct mistakes in their thinking can really make a
Mhm.
difference. It helps them fine-tune how they're using the visuals and really deepen their understanding of the content. It's not just grading the final product, it's guiding the process.
Right, you got to be involved, not just assign it and walk away.
Yeah.
What about collaboration, working together? Does that help?
Yeah, research shows some good things about that. There was a study where they compared students making concept maps alone versus in groups for a science topic. And guess what? The groups did way better in terms of the quality and complexity of their maps.
No.
Shows
Right.
that they were getting a deeper understanding by working together. Seems like that group setting lets them share interpretations, bounce ideas off each other, and build a more complete and accurate visual together.
Makes sense.
Different kids notice different things, have different strengths, and working together, they can build on each other's insights.
It's like the whole is greater than the sum of its parts.
Exactly.
Okay, so last up in strategies is this self-explanation and metacognition stuff.
Hmm.
How does that work with visuals?
So self-explanation is when you encourage students to explain things out loud to themselves,
Oh, okay.
often while they're working with the text and visuals. And this helps them process the info, spot gaps in their knowledge, make inferences. And metacognitive strategies take it a step further. They're about prompting students to think about their own thinking, basically.
Well, meta, right.
Right. And the research says that giving them feedback at that level where they compare their explanations or their visuals to, expert models or correct answers, that can be super helpful, especially for older students who might have misconceptions. But just telling them to self-explain, that might not be enough.
Okay.
They
Yeah.
might need specific prompts and guidance to do it effectively and to know what to focus on.
Right. Got to give them the tools.
Yeah.
Now, there was also a little bit about researchers' explanations, adding spoken explanations to the visuals and text. What did they find there?
They did a study on that, and it seems like having that multimodal approach, visual, text, and audio, it did help students' performance in the short term, regardless of how good they were with language. Interesting. So it seems like presenting information in different ways can give them more routes to understanding. It could be especially helpful for immediate comprehension. But there's not a ton of research here, and the long-term effects might be different.
Okay. So we've got the strategies and activities down. Last thing on instructional support was duration, how long students spend working with visuals. Does that matter?
Yeah, they made a distinction between short-term instruction, like how to use a specific visual, and those longer interventions that use visuals throughout lessons over weeks. One study compared a 4-week program focused on visual conventions to a 10-week one. And guess what? The longer program led to big improvements in students' diagram reasoning and their science content understanding.
Wow, so the time really makes a difference.
Right. The short one didn't have much impact, so it seems like developing that deep understanding of how to really use and interpret visuals, it's not a quick fix. It takes time, practice, and chances to use those skills in different situations over time.
Right, it's like any other skill. You got to keep working at it. Okay, so the research you sent also looked at the impact of VDs on different levels of learning, based on Bloom's taxonomy, remembering, understanding, applying, all that. What do they say about each of those?
Sure. So starting with remembering, things like vocabulary and recalling facts, they found that using visuals showed promise for boosting vocabulary in young native English speakers.
Okay.
Like connecting a picture to a new word seems to be pretty effective for that group. But the results were mixed when it came to remembering facts and main ideas from, informational texts.
So a picture might help a kid learn a new word, but it doesn't guarantee they'll remember all the facts.
Right. Just having visuals there doesn't mean they'll remember it better. It depends on how deeply they engage with that visual info and connect it to the text. Just passively looking might not cut it.
Makes sense. Okay, what about understanding? It seems like that focused mostly on reading comprehension.
Yeah, that's where a lot of research has been done. But remember, the results on how VDs affect reading comprehension are kind of all over the place. Some studies say good, some say no difference. And the researchers think that's because there are so many things at play: the specifics of the intervention, how well the visuals are designed, the students' individual skills and knowledge, even how comprehension is tested.
Yeah, it's
It's a
complicated.
big puzzle. No easy answers there.
Okay, what about those higher level thinking skills? Applying, analyzing, evaluating. You mentioned that VDs are used a lot in STEM to try to boost those skills.
Right. Visuals are common in math and science to encourage those higher level processes. And the research generally suggests that they do have positive effects, like using diagrams and models can help students break down math problems, visualize relationships, evaluate different solutions, and apply what they know in new situations.
So they help students think critically.
Yeah. But one study found that how well VDs work for this can depend on how old the students are and how the visuals are designed.
Makes sense.
So what works for older kids with one kind of visual might not work as well for younger kids, or with a different visual. You got to tailor to the situation.
Right, it's not one size fits all. And finally, the highest level, creating. The research said that even though creating wasn't always the main goal in the studies, it often led to significant learning benefits.
Absolutely. When students create their own visuals, they're inherently using those, applying, analyzing, evaluating skills to figure out the best way to represent the information. And the research consistently shows that this can lead to big learning gains, maybe even better problem-solving skills, and a deeper understanding. But remember, this often depends on giving them instruction, support, and feedback during the process. You can't just throw them in the deep end.
Right, got to scaffold, guide them through it. Okay, we've covered a ton. So for you, the listener, based on all this research, what are the key takeaways? What should teachers keep in mind when using visuals in the classroom?
Okay, so for those author-provided visuals, the big thing is alignment. Make sure the visual and the text work together, they're telling the same story. And if you're using those abstract visuals, diagrams, charts, that kind of thing, you got to provide support. Show them how to interpret them, have them explain what they're seeing and how it connects to the text, give them feedback on their understanding, and teach them those visual conventions explicitly. Don't assume they just know how to read those visuals.
What about when students are creating the visuals themselves?
Well, those fill-in organizers, they can be a great tool, especially for students who need more structure. And with older students, embrace those student-created visuals. They can really boost learning. But remember, clear instructions, ongoing support, feedback, all of that is crucial.
You also mentioned a specific use for those concrete visuals, like
Right.
photographs.
Right. For young native English speakers, those concrete visuals can be a really effective way to build vocabulary. Use them when introducing new words, or have the kids draw their own pictures to go with the word.
Okay, so visuals for vocabulary and for those higher order thinking skills.
Don't just have them read stuff with visuals. Design activities that make them really engage with the information, applying it, analyzing it, evaluating it, using visuals. Give them feedback on their creations. Ask them to explain their thinking when they're using visuals to solve problems. Have them work together on visual tasks. And think about project-based learning where they have to create and interpret visuals to show what they know. It's about active engagement, not just passive observation.
So the main message is visuals can be a powerful tool for learning, but you got to use them strategically. Think about the type of visual, how students are interacting with it, and the importance of that instructional support. Then you can really unlock their potential to help kids learn better.
Absolutely. It's about moving beyond just thinking, oh, visuals are nice, to a more intentional approach. How can we use them to achieve specific learning goals and meet the needs of all our students?
That's a great way to put it. It really makes you think differently about how visuals are used in education. Maybe you'll even start paying more attention to the visuals you see every day and how well they're helping you understand things. Maybe this deep dive will encourage you to look at the world and learning itself through a more visual lens. We encourage you to dig deeper into the research we've talked about today or explore related topics based on what you've learned. Thanks for joining us for this deep dive.
Thanks for having me.
Take care.